Math 1314, Tyler Junior College, Section 2.1, Basics of Functions and their Graphs. Function notation. In the previous video, we spent a lot more time than I wanted to, showing that equations can be viewed as relations because either an ordered pair makes it true and therefore belongs to the relation, or the ordered pair makes the equation false and therefore does not belong to the relation. And we spent quite a bit of time answering the question, when is an equation a function? In short, if an x value will always produce a single y value, or equivalently, if we can solve it for y and we only get one equation. There were two examples where we solved for y and we got two equations. One involved absolute value, one involved squaring. Now be careful, that doesn't mean the presence of an absolute value or the presence of a square instantly dismisses you as a function. It depends who has the absolute value and who is getting squared. But if an equation does represent a function, then we can probably write it in what's called function notation. Specifically, if an equation represents a function and we can solve for y, because I have seen equations that are functions but can't be solved for y. But if we can solve for y, then we can write the equation, excuse me, then we can write the equation in function notation. For example, here are the two equations that were functions from the previous video. Y equals x squared plus 1, and 3x plus 4y equals 12. Don't worry about the red part yet. The first one was clearly a function because if we pick a value of x and substitute it, we'll only get one value for y. The second one was not as explicit, but if we pick a value of x and solve for y, we would only get one value. If you have an equation that is a function and you can solve for y, then you can write it in what's called function notation. This first equation is already is already solved for y. So here's how you would write it in function notation. In function notation, you basically change the y to this. F parentheses x close parentheses. So, and this would be read f of x. F of x. So instead of y equals x squared plus 1, we can say f of x equals x squared plus 1. Now I'll comment on the f of x. It is not a multiplication problem. It is not f times x. It is f of x. Point number 2, f is not a variable. It is the name of the function. Now, we're using f right now because function starts with f, but the truth is the name of this function is completely arbitrary. We can use any letter we want except x. In some higher level math books, functions are called y of x to emphasize that the output of the function is y, but we will mostly see f of x. Every once in a while we'll see a different letter. Function notation isn't asking the question, am I a function? Function notation is saying, not only am I a function, I will tell you exactly what to do to the x to get the y value. In other words, think of this function as a machine that you're going to put a number into. The function will take that number, do something to it, and return a value to you. That's the output. So for example, let's take a look at f of x equals x squared plus 1. And let's say I ask you to evaluate f of 5. I think several of you already know how this goes. All you have to do in function notation is replace the x with whatever input you are putting into the function. So in this case, I'm going to replace the x with 5. And then do the math. 5 squared is 25, plus 1 is 26. When you do a function notation problem with a numerical input and get a numerical output, you have just manufactured an ordered pair because the input represents the x and the output, which is equal to f of 5, generically f of x, represents the y value. The input is the x, the output is the y. I like to think of functions as ordered pair generators. You feed it an x and it will generate the y coordinate, boom, ordered pair. Now sometimes function notation is a little, I don't want to say tough, but maybe a little trickier. For example, let's say I ask you to evaluate f of -3, which sounds pretty harmless. But here's a mistake I see the best math students make. Warning, what I'm about to write is incorrect. I'm going to replace the x with a -3. Let me get out my calculator because math is hard. This math's not hard. If you were to put this in a calculator, it would give you the wrong answer. It would give you -8, and it's not -8. You know what it is? It's 10. Why? Because what's the first thing I do to the x? Square it. And I know this looks like it says -3 squared, which is 9. 9 plus 1 is 10. But if you write this or type this in a calculator, you're not squaring -3. A square belongs to the thing immediately to the left of it. If you write this, you are squaring only the 3, which makes it a 9. And then after that, the negative comes in and turns it to a -9. To square a number in a calculator, you have to put it in parentheses. Otherwise, the negative doesn't get squared. The output is 10, the ordered pair is -3, 10. In fact, when you're doing a function notation problem and changing the x to some value, it's usually a good idea to replace the x with an empty set of parentheses and then fill in those parentheses, especially when your input is not a number. For those of you going towards calculus, you will see inputs that are usually not numbers but expressions. For example, let's say I ask you to find f of x plus h. Whoa, what's the h? Honestly, it doesn't matter. What matters is, what are you putting into the function and what are you doing to it? A function is like an action or a verb. This function says, give me something, I will square it and add 1. So when you're doing a function notation problem, if the input is anything of significant size, or even if it's not, you can always set up the function by doing the following. Take your function, x squared plus 1, but replace the x with parentheses. So instead of x squared plus 1, I'm going to write parentheses squared plus 1. Then substitute the contents of the parentheses into the parentheses. If the input is x plus h, put x plus h into the parentheses. Now, is there more work to do here? Well, the only other option you could do is to square this. Warning, don't write x squared plus h squared. There is no such distributive property. But squaring a binomial means to write it twice and FOIL it, if you will. I'm going to spare you the details. If we were to FOIL this, we would get x squared. We would get xh, but we would get it twice. So 2xh plus h squared, then plus 1. There are no like terms to combine, so this would be our final answer. So function notation is pretty straightforward, provided you have an equation that says y equals. That's if you're writing an equation in function notation. In the second function that we saw in the previous video, it came from the equation 3x plus 4y equals 12. But if we're going to write it in function notation, you first have to solve it for y. I want to get this out of the way. Didn't plan my board space well. We'll just lose that last one. If you missed it, go back, watch it, write it down. And by the way, that expression f of x plus h will show up again in this class. In calculus, it shows up early and it gets really annoying. And then you learn shortcuts. But anyway, if we want to write this equation in function notation, we have to solve it for y first. Now we had already solved it for y in the previous video, but it's not that hard to do again. The 12 is already on the right side. The 3x would move over and become negative, and now the 12 means it's plus. And then the whole thing would get divided by the number that gets the y by itself, 4. Now that's not function notation. That's the equation written in the form y equals. And so that implies that f of x is equal to negative 3x plus 12 over 4. You know what? I said that not all functions have to be called f of x, and honestly, that's the default name. But you can call it anything you want. We'll we'll call it g of x. Why? Why not? And so now that I've written this in function notation, I could evaluate this function at any input that I want. For example, let's try the x plus h again. Because I'm going to assume that if I give you a number, you can multiply it by -3, add 12 to it, and then divide it by 4, or at the very least reduce the fraction. But if we put in something like g of x plus h, then we would write the function but replace the x with parentheses. So instead of -3x, -3 parentheses, and then plus 12, and then divided by 4, and then substitute the input into the parentheses. The only thing we could do here is distribute the -3 to get -3x minus 3h plus 12 over 4. And that's as far as we can push it. If you're tempted to reduce the 4 and the 12, resist. The 12 is part of an addition problem. Addition and division are not opposites. There's no canceling there. You could split it into 3 fractions just to reduce the last one, but this is a perfectly acceptable answer. So, if an equation represents a function and we can solve for y, then we can write the equation in function notation. Now, the thing in red is not going to be an issue in this college algebra class. However, for those of you going towards calculus, there are situations, especially in calculus 2 and in calculus 1, there are situations where you have to view equations not as functions of x, but as functions of y. So for those of you who anticipate taking calculus at any point in the future, I invite you to continue watching. If you're not, then you can continue watching, but you're not going to miss out on anything that you need for this class. Let's take the equation that we just took as a function of x, but view it as a function of y. And remember, what it means to be a function of y is you basically flip-flop who you call the domain and range. Normally, x is domain and y is range. But to be a function of y, you would say y is domain and x is range. So this spiel about if an equation represents a function should actually say a function of x, and we can solve for y. But the letters are reversible. If an equation represents a function of y and we can solve for x, then we can write it in function notation. So if we were to write this as a function of y, we would have to solve for x. So if we solve this for x, we get x equals -4y, because we move the 4y's over, plus 12, and then divide by 3 to get the x by itself. So we could call this a function of y by replacing the x with something like f of y, -4y plus 12 over 3. And then do all the same things that we did before. So heads up for those of you moving beyond college algebra, eventually towards calculus, you are going to be put in situations where you have to view equations as functions of x and as functions of y. Now, as a function of y, this simply means if we pick one y value, it's going to pair up with exactly one x value. Remember, we're switching who's the domain and who's the range. So it should be pretty evident that this is a function of y, because if I put a single value here for the y, do the math, I will end up with a single value for the x. All right, so equations as functions, function notation is pretty straightforward. Again, for the college algebra class, it's almost always going to be a function of x, although that is actually quite arbitrary.